And about me, I have around 17 years of experience, and I started my career as a hardware networking engineer. Then I became a Intel, then became a Linux engineer. Then I became a middleware engineer, then translated to the architect. Then I board of architect, became an engineer again. Then again became a manager, again board, again started as an engineer. Currently, I'm working as a DevOps engineer. Before that, I was working as a data platform engineer, and as well as I worked as a data science system engineer. And yeah, my passion is I love to learn the new things and unlearn it, relearn it, and always happy to share with you guys. Happy to share in a community, as well as happy to help to the college students. Okay. And I have around 50 plus certification, and I always take credit on the certification on the TOGAF. It's a really tough certification I went through. A lot of theory concept. As everybody know, engineers and architects, we love to see everything in visual. The TOGAF is more as a conceptualized one. Okay. Okay, session details. We are going to talk about very simple thing. Okay. So anybody want to switch on also, you can be on this. So we are going to talk about DevOps. Then MLOps. We talk about what is MLOps and how it is different from DevOps. Then we'll have we'll give a demo, how we can deploy your model, like how the developers deploy the code as a machine learning engineer or a data scientist, how you deploy your code or model. Then we'll take a feedback, and also I give some slides, the good learning point which I taken while I'm starting learning about the MLOps. Okay, how many are here are doers? Forget about talking. I just give me the code, I will start doing it. Developers, okay. At the end of the session, okay, this guy is speaking a lot, I don't know anything, just tell me, show me the code, okay, for this guys, okay. This slide will be presented to you guys, okay. So you have a GitHub link, we'll have all the step-by-step instruction, including the code, okay. I'm not a big Python developer, but I can develop a Python. It's small Python code, machine learning code we developed, deployed, and you have everything here, as well as whatever the lab we are doing, it's have a step-by-step screenshot. If you're stuck, message me, I can help you, because we need to have a takeaway from the session, okay. So people really want to interested in doing something after the session, please you have to invest 2 hours to 2.5 hours to do end-to-end, okay. And please delete after you finish off, otherwise it will charge for you. Okay, again what you learn, you definitely learn what is MLOps. You cannot, after this 45 minutes, I won't say that you'll become MLOps expert, no. But definitely you will get a concept of what is MLOps, and you can talk to the people what is MLOps. And how to apply the DevOps principle. Now everybody knows DevOps. Anybody don't know DevOps? Not heard about the word called DevOps? Okay, so everybody know DevOps, okay. So with your knowledge, this will be additional stack, how you can work with a data scientist and data engineers. Of course, we will do the demo. Okay, I want to know a little bit about the audience. So I want to make sure that I'm covering all the bases. Front-end developers, back-end developers, full stack, mobile, web. Okay. And SRE, wow, DevOps, architects, good, okay. You have a mixed crowd, okay. And data scientists, data analysts, data engineers, data scientists. Okay, thank you. So this session is there for everybody, okay. So we have some points which you may be benefit, and some points that DevOps and the architects can be benefit from. How many people seen this slide before? Good anything, anywhere? Okay, okay. It's a very common thing, okay. And this is the same practice Swami has covered. So what we do, where the DevOps come into the picture? At the ultimate, what is going to help? Previously, everybody is developing, everybody deploying on a code. We are sitting happily 15 years back. But what the DevOps changed? Of course, it helps us to foster time to the market, and you will capture the failure, and you will develop fast, you deploy fast, you fail fast, and you do the iteration fast, okay. That is where the DevOps helped, okay. And it has a practice. It's not like this company A is doing something, they are working well, I'll take it and apply it to my company B. It's not going to work. So same thing. These are the concepts I think last session I covered. Continuous development. Okay, what is continuous development? Same point he touched upon for me. Around 50 developers are there. Okay, we cannot say I develop and I will send it to you. You develop, you send it to me, and it is something not the new generation or the last 5 years. Nobody knows about it. Think about 15 years back how they were developing. Hey, I developed, okay, I'm sending you to the floppies, okay. I sending a mail or keeping in drive, you develop, you send it to me, I will verify, I'll merge the code. Now we can go to the, now it is completely different. Continuously people are developing, 50 members in the team, everybody take a modules, everybody created their feature branch, everybody develop and team lead will go review the code, merge it to the branch, and so this is called continuous development. And continuous code testing, it's really, really important. And how many people are doing a continuous code testing in your DevOps practice? Continuous code testing. So you mean you test a whole code or you test the piece by piece? So you have a functional case, you take and you build a code and you run a test case for that particular function and check whether it is working or not. This is continuous testing, the code quality. And security. How many people copy paste and you find the issue on the production? You taken a code from somewhere and you deploy it, everybody is happy, we went very fast, everything is in production. Oh my God, something got hacked, okay, we have to go and patch on production. So that is the exact scenario they need to avoid. They want to make sure that the code is completely scanned, because everybody using a libraries, you take any framework, say Python, or you take a Node.js or Java, everybody is importing a framework, and it's a lot of bunch of pre-built libraries will be there. So you need to make sure that your code then a continuous security testing. Then continuous integration. Any example? Continuous integration. So microservices. Anybody working on microservices? I want to make it simple. Any microservices. You have one web app and you have two backend application. This need to give a you have one front end and you have two backend. Okay. It need to work integratedly. Okay. And while you are deploying, sometimes you need to do the proper testing while doing the deployment. So the DevOps practice help you to continuously integrate and test before you do the deployment, okay, whether the integration is working as expected. And delivery and deployment. What is the difference between continuous delivery and deployment? How many people are deploying to the production with approvals? Very simple. And how many people are deploying to the lower environment with approvals? Okay, you are all doing continuous delivery. The moment they commit the code, it build, it will compile, it do the testing, and it deploy. Okay, before that you do the checkpoint after. But how many people confidently deploy to the production without doing the approval? Okay, but do you think there are organizations not doing this? How many people can agree that a lot of companies are doing a production deployment without the manual approval? Yeah, they do, okay, because they have a complete best practices. They do the code scan, they do the code testing, they do the quality testing. So if you have that much confidence on your application, you can do the deployment. As well as same thing, you will, in case of any issues, they have a proper rollback mechanism. If you have everything, you can do the continuous deployment. And monitoring is very important while you are doing an application, particularly on the microservices application. Monitoring is very pivotal. Monitoring, high level, I can say errors, logs, metrics. If you have all three, your microservice application, if it throws the error, you get to know and you can take an action. If you give a metrics, say the traffic went up, traffic went down, and the latency is up, latency is down. So based on that, you can make a decision. And infrastructure as a code. Anybody is not doing infrastructure as a code. I just create a Python application. I develop in my laptop and send it to my neighbor who is putting in a production. Anybody doing that? And EC2 instance, I go to the AWS console, or any instance you want to create, go to the Azure console, click, create. Okay. So if you want to have a best agile practice, you need to make sure from the day one or any new project you are doing from now on, practice infrastructure code. Okay. And you can use any tool the advantages comes in a longer run if you want to replicate the same infrastructure stack again and again, or you want to version your infrastructure. The infrastructure as a code is very important. Of course, we have practiced all the practice. What is outcome? We talk about faster product delivery and automation to improve the efficiency. Whatever the way you are deploying now, it will definitely improve the efficiency. Shift left approach. Anybody is hearing this terminology? Shift left, okay. Particularly security team. Oh, we found issues here, okay, don't do it, use shift left. That means the same thing, you do the continuous code testing. In the diagram, I don't want to show this diagram because it's boring. The reason I want to put this diagram is, don't deploy and then find out the problem. Try to, at the code, at the stage of build, at the stage of planning, at the stage of testing, you do figure the problem. That's what the shift left. This is a curve, right? Just put up a horizontal line. Try to capture all your security as well as your functional test, everything on the left side of this corner. Of course, it gives a quality deliverables. If you are very much 100% confident, I commit my code, it go to the production. In case of any issues, I just roll back in a quick manner. So, of course, the canary deployment come into the picture and blue-green deployment come into the picture. But still, if you are very much following the DevOps practice, the ultimate aim is, I commit my code, it needed to go to the deployment, it go to the production quickly. It's not like every day I do one release. Whenever I want, I can do the release, okay. There is an issue that need to have a rollback mechanism where I can do it in a confident manner. I can do all those things if I'm following the best practices. Okay, I'll take a small use case, okay. Imagine there is a company called Institute, okay. So I just came out, okay. So this company is a startup company. They are providing a insurance for the premium customer who own the yacht. They already a insurance company and they already built a web and mobile application for other insurance. Now the CTO came and instruct, okay, now we want to build a separate insurance for this yacht company. So I want you to build a front end, back end, but you know, CTOs, they were in part of many groups. They know the best practices. They say, whatever I'm building, it need to have a cloud interoperability. At the same time, you guys need to follow the best and you need to make sure that you follow all the DevOps best practices. And whenever I want to do the deployments and no downtime, fully tested and fully secure. Anybody get this kind of instruction from your C team? Okay, this is a common expectation from the C team. I want to do the any application you're developing, I want to deploy in multiple times and with a zero downtime and fully tested and secured, okay. So of course, the DevOps team came together and started working with the development team, and then they build a pipeline and they do the deployment. I'm giving a simple pipeline they prepared for the Python application. Is it visible? Somebody at the back? Okay, so I just created a very simple thing. They are using Python and they're using SonarQube. Anybody working in their infrastructure SonarQube? Okay, I do the code testing. So we were talking about the shift left approach, right? They do the testing, whether the code is good or not. If it is not in acceptable rate, the code will not, the pipeline will not go. That means it's stopped there. Then they will install all the Python dependency. Again, they do the unit test. They build a functionality for the backend, right? They do some small unit test. Then they deploy the test result. Okay, I did a unit test. What is my result? Every time I deploy it, I want the results to be compared between the next release and this release. They'll keep the test result and they're building as a Docker. Why they want to build as a Docker? Why they want to deploy using a Docker? Because that CTO told it need to be cloud interoperability. So anytime they want to make it to the data center, same image, Kubernetes, they can make it. If they want to go to the different cloud, they can do it. And they want to test it in a local, the same image they can test, okay. So that's the advantage of it. For that, they create a ACR. ACR is nothing but a repository for keeping your image. And building with the Python, they're building a Docker image. Then they do the aqua scan. So now good, I did taken a code, I did a quality test of my code there. Now I build a container. Why do I need to do the scan here? Because in a Docker file, people can export from other base image. That may have a vulnerability, okay? And we don't want a code to go to the production without testing. That's why they are having AquaScan as product which can do the container scan. Now we are doing a container scan because now we know our code is also tested, our image is also tested, our code is secured now. Then we upload that image to the ACR. Then we are installing the Helm chart also. Helm chart is nothing but a declarative about how we want to orchestrate your deployment, and build and deploy to the staging. And again, after doing the deployment to the staging, we do the one more round of testing. Whether now that I deploy to the staging, I have the new URL and I give you the payload and see whether the application is working or not. Because all the application will work. Why do we need to do this test? Because at the end, the data will differ. Okay, we need to do the data testing. Okay, whether the URL is responding as expected or not. So we do the endpoint testing. Then whatever the working image now, we say, okay, go to the production. Of course, you need to have multiple stages. Since I was talking about continuous deployment, I just directly go to the production. Anybody can add some items which I'm missing. Definitely, I know I'm missing something because you guys in your infrastructure, you would have learned something. Anybody add something? Go on, please. Versioning, okay. Yeah, monitoring, okay. Now the only deployment is done, okay. It's just one piece of it, continuous deployment is done. Of course, you need to do the monitoring. For the front end, you need to have monitoring for your latency, whether the latency is good or not. Back end, you need to do the data testing. At the same time, in case the application is throwing an error, you take the error logs and start alerting. That's a continuous monitoring you need to do. So, I've not taken it, okay, just whatever I thought of, it's a best practice I put it. But I went, the same thing I was discussing with somebody, they challenged me with a few more things, like multiple stages need to be there and need to have approval gate need to be there because it's a best practices, okay. So that debate will be there. I say, no, continuous deployment is my ultimate goal. They say, no, continuous delivery, we stop there because production is production, okay. Yes, okay. So still there are a lot of security things has to be done, okay. So we are doing only the code scan and container scan, but still I feel the data need to be secured, and while you are paying the payload, you should not give a random payload and should not dump the payload. So a lot of testing has to be done. So what they will give, so if everything is working fine, you achieved it, what do the CTO will do? They give more money for the hike or give you more work? So, you are right, okay. They given them more work. Now they have a new use case. Guys, very good. Now we have a web application, everything done, but they are premium customer, okay. It's not like they submit the application, they wait for 3 days, and you guys can come and tell, oh, we will not approve your claim because you people drive crazily frequently, so we will not approve your claims. No, they want to instantly know whether they approve or not. That is a use case they have given. So they call the data engineers, guys, you have many customers now, they submitting the claim where the data is stored. They're saying, okay, it is going to the database, okay. Good, you have a data set now, okay. Why don't you build a model? They ask the data scientists, why don't you build a model, come up with the details, whether the moment they submit the claim, they will say, yes, this could be approved, this cannot be approved, this can be denied, okay. They said, okay, we will be able to do it. Then they call the same DevOps guy, good, the same way you did it for development team, work with the data scientist and put the model to the production, same logic, I will deploy as much as want, as much time I want, and it need to be in internet scale. So you got this use case, right? At least correlate. Okay. So anybody not into the machine learning? The moment I say the word called machine learning, I just turn my face. Okay. Okay. What is? So this is a simple comparison I gave. Now I'm working with developers as well as a machine learning engineer. I can find some common generation. I put it in my own words. So we want to create a microservices. They gave a Python. We build a logic on it, okay? And we know these are all the data to be used. We keep it in a data store. These are the data to be done. So I create a logic, heuristic rules, and that will be deployed to the production. So this just the simple web application. I collect the information. The moment they submit, my backend will go, store it, validate the entry, and store it into the database. Well and good. This is the developers do. The data science team, they're building a model where the data can be any format. Based on this input will be differ from one customer to another customer. That is a payload. As a data scientist, I get it. I cannot have a rules here. I can create a general, I don't want to go to the model or logic, just keep it as a logic, just for the better understanding. That need to be generalized, okay? The model need to be generalized and give me the output, yes or no. I'm giving a simple example. So we will label the data. If this is a customer and who drove for 200 hours and they never had any problem, suddenly they faced some issues and they submit the claim, they may be genuine. We can approve them. And there is a customer every 3 months, they will bank somewhere and raising a claim. The high probability we say no. So based on that, we will write our machine learning model. We train our model with all the parameters and we'll give a logic. So here, the code is an output and here the model is an output. So you got it right. It's not a very tough thing. It's a very simple thing. So while you're learning machine learning, everybody's talking about big thing. Okay, I just want to keep it in a very simple manner where everybody can understand. 3 things: classification and regression. Classification is nothing but this is the data. I'm telling the data. If this is, you just tell us a rectangle, this circle, you just name it, and I'm training the model with this label and giving the new data. Based on my training, it will say, okay, this is rectangle, or this is a triangle, a circle. If they are able to do, it's a classifying it, okay? It's a classification. And that is a regression, nothing but I walked 10,000 steps, today I walk 12,000 steps, so and so percentage increase. Tomorrow I'm walking 15,000, so and so step increase. I'm continuously doing it. In certain period of time, I'm growing. I can walk a little bit more. It's a linear regression, okay? So example is sales and how we can forecast. Based on that, we can forecast after 2 years how much I can walk. Logistic regression, nothing but I applied the loan based on my CIBIL score and so on, so parameter, everything, whether they approve the loan or not. So nothing but yes or no. And probability. What they are not going to tell yes or no immediately based on our threshold. Okay, if it is more than 0.75, say no. If it is more than less than 0.75, say yes. This is the logistic regression. Okay, it's very simple. We no need to read the white papers and everything. The conceptually, it's a best way of understanding. Okay. Then we have a clustering. Same example, nothing but just drawing a line. I'm not talking about the algorithm and all those things. Just drawing a line. Hey, come on, that is a rectangle, this is a triangle and circle. Okay, this is clustered the one. And same logic, you see the red, that is anomaly. It's figuring out this is anomaly detection. Okay, this is unsupervised learning. We are not labeling the data. Previously, we are labeling the data. If you are label the data, it's a supervised learning. If you are using unlabeling the data, it's unsupervised learning. Very simple. I explained in a simple manner. People who are not aware of machine learning, you got some idea about it now? Okay, thank you. So this is the one I'm passionate about, oral reinforced learning. Simple way to put it, I'm not going deep into it. The best example is autonomous vehicle. So it's not like a single machine learning into it. There are a lot, whether if I'm banging on the left side, I get into this wall, I say, okay, this is wrong, don't go there. It's a feedback loop, nothing but yes or no. We have some mechanism like an agent. If I'm doing good, it will give yesterday I'm not sure we attend the session. If there is a carrot and stick, if the dog is doing good, give a carrot, the donkey is, and if it is not doing good, you give a stick. Same logic, okay? If you are doing good, you give a reward. If it is not doing good, you don't give a reward. Based on that, it will continuously learn. And autonomous vehicle is using that. Yeah, of course, you have multiple input, camera, LiDAR, lot of input will be there. But the concepts wise, that's all. How many people seen this before? Great. Okay, thank you. So in the circle, right, in our DevOps, it starts with the code. Here, where it starts? It starts with the data. Okay, for a DevOps engineer, where it will start? Say package. Okay, plan, okay. So it's a cycle, okay, it's an iterative process, okay. So I start with the data, and I was learning, okay, so the very important thing I learned from our fellow data scientists, they agree on not a robust model is important, quality data is important. Data scientists agree on it. You want the latest and greatest model and give a bad data, or you want the good data with the recent model? Okay. How many people train the model from the scratch? How many people take it from the GitHub and start using a trained model? Okay, nothing but same thing, copy the code or develop the code, okay. So most of the people use that pre-trained model and have a good data which give a better model. So we have a cycle. I'm going to use a demo. I'll walk through the reference framework, then I go to the demo and I will start from the data, exploratory analysis, and then model, release, predict, and monitor everything. I'll do it. So this is a reference framework from Azure. Anybody seen this before? It's not late, it is very latest, but if somebody knows, I'm happy to discuss with them further. Okay. It is announced, it is developed by the Azure. This is a link I have given, it's taken by Azure, from the Azure. So it gives a reference framework. If I want to build a end-to-end infrastructure for the machine learning team, what do I need? Again, here, these numbers talk very clearly. Everything starts from the data, okay? The data need to be, is it too small? Okay, so the data, let's start with the data. It's a storage, Azure storage account, and it can be a data lake, or it could be a SQL server, Cosmos DB, Event Hub, Snaps, and to the people who not working in Azure, Azure is nothing but a blob storage. Say data lake is also a blob storage, and yeah, you have additional feature. SQL is a relational database. Cosmos is a NoSQL. Event Hub is like a Kafka. Snaps is like a data warehouse. And feature store. Anybody worked on a feature store? It's very important for the machine learning. Just give an example. I made a very good data, okay? And I want to make sure that the people who are building a new model want to use this data. And I have all the information about where I collected the data and what is the quality of my data, everything. It's nothing but a metadata. They keep it in a feature store, which will be used for the training. The data comes from, then comes the important part, the same logic what we use in a development. We need to have a repository, like how we have a code, any kind of GitHub or repository, and machine learning workspace, nothing but like how for the developers you have IDE, you need to have workspace. Of course, you need to have a data, and to test the data, you need to have a compute, and who can supposed to access the data, who not supposed to access the data. You need to have defined users, and also we need to create a monitor, who is accessing the data and what. This is more as the administration setup. We will do all those things in a demo, okay? At least I can show you how we are doing it. Then this is where the data scientists work. They get the data, they explore the data, and then they do the feature engineering. Feature engineering is nothing but adding additional features to give the value to the data, okay? I keep it in a very simple manner. And develop the model and train the model, and again they do them in a repeated fashion, okay? Until they get a expected response, they develop the model. Once they develop the model, we register the model. What is a development? We have code, we deploy. And the machine learning ops, we have one more important parameter. What is that? If you are building on web application or say on backend application, or say Python or Node.js, we have a code and we do the deployment by the package. But MLOps or machine learning, we have a code. Along with that, we have a data. Then we have a model, okay, like how package. So here, it's not only we are versioning the data, we need to version, not only versioning the code, we need to version the data also. Because like how frequent, I will show the development, how they do the deployment. It's not like everyday deployment, every hour deployment. Some models, the moment you ingest the data, within an hour, they retrain the model and deploy it, okay? So for continuous integration, we are going to use the Azure DevOps And for registering our model, we are going to use the Azure machine learning. We will go through this one. And of course, this is a quality test. We do the quality test, data test, unit test. And the last part, you need to understand the batch inference and near real-time inference. Batch inferences is nothing but I build a model, I deploy it, I'll give you huge amount of the data, it will run slowly and predict it and keep the data into the data store, something like your Azure storage account or not. Real-time inference, the classic example is like a voice over interface, like Alexa or something. You are making your input and it is processing and giving you an output, real-time inference. Like how we are going to do the deployment, the moment they submit the claim, it will go provide the data and to the another API and get the prediction whether they are eligible for this claim or not, okay. So this is a real-time inference, okay. And of course, batch inference need a lot of compute based on your data, and real-time inference based on your volume of the concurrent request, okay. If nobody is calling Alexa at 10 o'clock in our India, we are not going to get a packet. And if everybody talking at morning at 9 o'clock, we will get a lot of payload. And of course, production, you need to have you're right, I accept it. We need to have a gatekeeper for production, whether before deploying the model, you need to validate whether it is giving the expected prediction result. The good thing, the real-time use case while I'm seeing in a production, right? They deploy the model 100 times, okay? Model 1, model 2, model 3, model 4. But not all the latest model go to the production. They keep a threshold saying that if this model is giving a better throughput and do the proper data validation and model accuracy, take this model to the production. Otherwise, don't disturb the existing model, let it be in a production. So this is the logic I seen in a real time. And of course, very important, monitoring. The Azure application sites will give you a monitor whenever you are making a call to the real-time inference. It will tell what is your throughput for the API, and you need to monitor the model and the data. What changes happened between one version to another version, okay. Today, I have 50 claims and I predicted. Tomorrow, 20 people submitted the claims. And while I'm training the data model, I need to include those 220 claim also. So it became a 50. So the first data set is having a 30 record and the second data set has a 50 record. So we need to version the data also. Why? Because if I get a bad data, my complete model will collapse, okay. I need to go back to the data and retrain the model, okay. So that's why the data versioning is very important. And the infrastructure, of course, you are going to use the compute, you need to monitor the infrastructure. And in case the triggers, notification and schedule, the same thing I told. If the model is not giving a better accuracy, trigger it, don't go to the production. Just roll back the change. Okay, this is the image of this. I just keep zooming it because I got a feedback, it is not zoomed enough. Same thing, it's data. We're setting up the infrastructure for the data science team, and we have an inner loop. The data science team keep developing it, and DevOps pull their sleeves and help them on deploying it, and they continuously deploying on the staging and lower environment production, and we have comprehensive monitoring. This is the framework Azure recommended. All the tools, the Azure is there. We will see. Okay. So now it sees, right? You guys agree? This is what we are doing it, okay? Get the data and explore the data, plan, release, predict, and monitor. Okay, I'm going directly to the data. So it's nothing but the insurance data. Okay, it's CSV file. Okay, don't ask me why I'm having CSV file. I should take it from S3. For the use case, I take it to the CSV. And this one, if we can see the version, if I want a new version, I can add a data and add as a new version. Okay, before going there is nothing but Azure Machine Learning Studio. Okay, so in Azure there is a Machine Learning Studio, which is kind of IDE for the data science team. It will give a complete infrastructure for doing the machine learning, give a notebook, and you can have a no-code machine learning model development, and you can version the data. This is what I'm seeing. I have only one version. You can see the version of the data. Then you can build a pipeline here itself, but we are using Azure DevOps pipeline. And you can see the model. I developed the model. Everything we do a code now, okay? So we developed the model, and it created the endpoint Okay, now I will create an endpoint. Now I not deployed it, I create an endpoint. So this is the Azure Machine Learning Studio. It's free, you can explore it. If you are running compute, try to stop it earlier. So I'm coming to the DevOps pipeline, which I will show how I build a pipeline. It will be exactly similar to what we did in a DevOps pipeline, little bit different. So guys seeing it, right? Okay. So same Python, installing Python requirement and publishing the test result. And Azure, there is a CLI, Azure CLI. We add the CLI and we create a machine learning workspace, like how the workspace I have shown you, right? That we can do via code. And I create a cluster and upload the data store. The data store, currently I keep it in a storage. It take the data from the storage and it keep the metadata and update the model registry whenever before deploying the model, it updates the model registry, train the model and register the model and download the model and keep it as an artifact. Nothing but the same procedure we did. We added extra things, train the model, register the model. So we are following the same DevOps practices for the machine learning with their best practices. What am I going to do now? I'm going to run the pipeline, take some time. Okay, I'm going to run this pipeline. What does it do? It will follow all the factors. Okay. So it's a DevOps session. So guys, you can, the lab exercise which I have documented in a GitHub, you can, all the steps are one by one, okay. So I install the Python requirement, I train the model, okay. Just skipping a little bit fast in the interest of time. This one I really interested to show this one. Now you deploy the model, okay, your CTO is happy, okay. Your model is giving accuracy of 90%. Everybody is saying, wow, after 1 month, it is giving accuracy of 50. Okay, and then they go back and check. My CTO is asking, what data processing pipeline you have? Because data is a fuel. Okay, it's like we're having a very good car, but what is a fuel? It's a fuel. Okay, what kind of processing you have? Data processing. It's a very important thing. So I just put up some thought on it. So once the claim is submitted from the microservices, what does it do? It go to the event hub. Event hub is nothing but it's a Kafka. So it stores the event data, and there's Azure Data Factory. Directly get the data every 12 hours and store the raw data into the data lake storage. Then our pipeline, we were running a pipeline, right? The pipeline will run. What does it do? It take the data, train the new model, build the model, and deploy the model. And at the same time, it store the trained data into the storage. That's what we are doing. So this is very important. Anybody disagree on this? Okay, thank you. So this is the demo we are doing it. As I told, we have 100 developers, we can work on it. The same thing, the DevOps also committing the same code into the repository. Data scientists also committing their code, the Python code, they develop the model. And DevOps will commit the infrastructure as a code. All the pipeline we created via infrastructure, what are the pipeline I shown before? It's all created by infrastructure. That's why you can quickly finish this lab. Okay. And the moment they commit the code into the Azure repo, automatically the pipeline will trigger, which will train the model, validate the model, and deploy the model to the Kubernetes. So I'm waiting for the training. Once done, you can see whenever there is a call to the model, you will see the monitor from your application insights. Okay. So before going there, I will let the pipeline run. I'll see what is the status of the pipeline. It will take time, okay, but I think it will finish in another 6 to 7 minutes, okay. But at the same time, let it develop. Meanwhile, I do the deployment also, so I can show it from the Kubernetes console. So once it's developed, there is a release. I agree on it. I'm not doing a continuous deployment to the production. I'm doing a continuous delivery. Creating a new release. The moment the new one come, I'll have a new version. Currently, it is showing me the previous version. I'm creating the newest version. And this is another pipeline. What does it do? It takes the artifact which we have deployed before and deploy this to the AKS. Because that is a platform, we deployed our backend logic and the front-end logic. And the same place, we are deploying our machine learning model also. So I'm waiting for to deploy. Once it's deployed, we can see from here you will see the endpoint, and with that endpoint, then if you are giving a payload of the data will be like this format. The moment you give the data, it will give a predicted output whether we can approve the climb or not. Okay, so I'll wait for this to go. It is registering the model and uploading here, right? It is building the model. Okay, here registering model is after that we build the container. Okay, it's a container artifact.
Oh, thank you.
In the code you can find it. I really don't want to go to the code review. Okay, so the deployment done. I'm not going towards EKS because of the interest of time. The model is here. It deployed the new model. You can see the timing, and if I click on the model, it give me the new version and it'll give me the new endpoint. Okay, it give a new endpoint and the endpoint can be used for making a call. So thanks.